Okay, so for part 1, these are just regular stoichiometry problems. So question 1 is asking you to convert moles of H2SO4 into moles of water. And so I have at the top of your worksheet, I have this written out. And this is the order that your conversions will always go in. Here, let me zoom in a little bit. Okay, so A is whatever substance you start with. So in this case, H2SO4 is our A, and H2O is going to be our B. Okay, so we are starting with moles of A, and all we need to do is convert to moles of B. So this is just one step. Okay, so you're gonna draw your chart, and you always put in this first space what you're given. And in this case, we have 1.52 moles of H2SO4. Okay, you're gonna write the unit down at the bottom always. So whatever unit you have up top, you're just automatically gonna bring it down. So moles of H2SO4. And a lot of people will try to bring down the number as well. Don't write the number, just the unit. And then you're gonna figure out what unit you're trying to convert this into. Okay, so we know that moles of A, our next step is to do moles of B. So I'm gonna write moles of H2O on top. From here, I use my mole ratio to convert between moles and moles. So on your balanced chemical equation, whatever coefficient is in front of H2SO4 is what goes right here. And in this case, it's just 1. And then the coefficient in front of H2O is a 2. And so since my unit on top matches what I'm looking for, I know that I can go ahead and stop my conversions and just solve. And to do that, I would multiply all the numbers that I have on top and divide by what's on bottom. So I would plug in my calculator 1.52 times 2, and then you can divide by 1, but it'll get you the same answer. And then whatever that is my final answer. Okay, for number 2, it is given me the moles of H2SO4, and it wants me to convert them into moles of water again. Okay, so I'm gonna set it up the exact same way, just this time I have different numbers. So I always start with my given, which is 2.67 moles of H2SO4. My next step is to always bring down my unit. And then I have to ask myself what I want to convert my moles of H2SO4 into. So just like how we did up here, we're going from moles of A to moles of B. So I'm going to put moles of what I'm looking for, which is water. And then I will use the same mole ratio because I'm using the same balanced chemical equation. So for every 1 mole of H2SO4, I can form 2 moles of water. And since my unit on top matches what I'm looking for, I know I can go ahead and solve. So I would multiply these 2 numbers in my calculator to get my final answer. Okay, for number 3, this one is asking us to go from grams of H2SO4 to moles of water. Okay. So this time we're starting with grams of our A, and we're gonna have to go all the way to moles of B. So this time it's gonna be 2 steps. Okay, so again, we're gonna draw our chart and always put what you're given in the problem. So 50.2 grams of H2SO4. And then we bring our unit down. And then you have to ask yourself what you're going to convert your grams into. So if we look up here at our little map, we go from grams of A to moles of A. So I know that I'm going to write moles of H2SO4. Whenever you convert from grams to moles, you use a molar mass conversion. So you're always going to put a 1 next to the mole, and then you're going to find the molar mass of H2SO4. To do that, you look at your periodic table and you add up the weight of 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms, which comes out to be around 98 grams. Okay, and so we haven't found what we're looking for yet, so we're going to keep going. So I'm going to add another section to my chart. I bring my unit from the top down, moles of H2SO4, and then this time, I'm right here. I've converted to my moles of A. Now I need to convert to moles of B. Okay, so on top, I'm going to write moles of my B chemical, which is water. Okay, I'm doing moles to moles, so I'm going to use my mole ratio again, which I find from my coefficients. So I have a 1 in front of my H2SO4, and I have a 2 in front of my water. And now since my unit here matches what I'm looking for, I can stop with my conversions and solve. And so I would do 50.2 times 2 and then divide by 98, and that would give me my answer.